Hello everyone, welcome to Tech-Lavya. Please like, share and subscribe.
The topic for today's lecture, students, is the short circuit test of transformer. Okay, that is also known as SC test. Now, in last lecture, we discussed open circuit test, and we know that open circuit test is used to find out the core loss, and short circuit test is performed in order to measure the copper loss. Okay. So basically, the aim of this test is to find the copper loss at full load. So we have discussed no load and full load condition. We know what happens during full load condition, isn't it? Now when we measure the copper loss, in addition to that, here we also measure the equivalent resistance, equivalent reactance and equivalent impedance. How are these quantities represented? The copper loss is represented as WCU. Okay. Equivalent resistance is represented by RO1 or RO2 depending on whether we are talking about primary or secondary winding. Similarly, equivalent reactance is also represented as X01 and X02. X01 is for primary and 2 is for secondary. Similarly, equivalent impedances. Okay. So again, before going to the actual diagram, I'll just tell you how to remember the diagram for the drawing. Fine. Okay. So here we have the variac to which the input voltage is applied, and since here we are talking about short circuit test, we will use the subscript SC. So VSC is actually the primary voltage only, okay, which was earlier represented by V1. But here instead of writing V1, we are writing VSC just to make everyone understand that this condition is short circuit condition. See, in open circuit condition also we used a parameter called VO. So V0 or VO. Okay, basically it also represented V1. But that letter O is actually 0, not, which represents no load condition. So if you say V0, it is no load voltage. If you say I0, it is no load current. Basically, these are primary current and voltages. Similarly, here we represent the voltage by VSC. It is short circuit voltage, and current will be represented by, say, ISC. Okay, fine. So this is done. Okay. Now the next condition is we need to have a voltage because we have to measure how much voltage we are applying. And then we have the wattmeter because we have to measure WCU. Okay, so this will give you copper loss. This is basically wattmeter. Then you have the current. Okay, so this current has to be measured. So we have an ammeter. Finally, this goes to the HV side of the transformer. Remember, SC test is done on HV side. With LV side, short circuited. So this is short circuited by a thick wire. Okay, so we use a thick conductor. Fine, and we short circuit this. Okay, so here we have I2 now. I2 is not 0 because now we have short circuit. But then since we have short circuited, the voltage becomes 0. Okay. Now please remember, I am going to write few important points. Okay. Now here low voltage is applied. Low voltage is applied. Now why low voltage is applied? Low voltage is applied Because the core losses depend on the voltage. Now, since low voltage is applied, my core loss will be negligible. Okay, so here core loss will be negligible. So whatever reading my wattmeter gives me corresponds to copper loss. Fine, because here now there is no load current, which was very small in the earlier case. Now here we get a proper current, right? So this corresponds to copper loss. So here core loss is going to be very small. Okay, so now I will get three readings. First is the wattmeter reading, which gives me the copper loss. Okay. Then I get the ammeter reading, which gives me the primary current. Then I get the voltmeter reading, which gives me the short circuit voltage. Actually, short circuit voltage does not mean this, the voltage which is applied at the input. Now, why do we require? Because we need to know how much voltage is getting applied. Fine. So, is it clear? Yes. Now we shall go to the ready-made diagram. See, this is how it looks like. Okay. Yes. So when I draw the equivalent circuit here by neglecting all the components, because core loss is negligible, so I can very well neglect R naught, correct, and X naught, so that whole branch is neglected. So remember, we had already drawn the smallest equivalent circuit when we were studying the equivalent circuit. So yes, so here we have VSC getting applied. Okay, then you have the current. Here you have R naught 1. Here you have X naught 1. Together they make it impedance Z naught 1. And here it is short circuited, and hence V2 becomes 0. So this is the simplest equivalent circuit for this SC test. Got it? Okay. See, this was the equivalent circuit. Okay, so what all parameters do we get? Here we get the power, which is the copper loss. Okay, then we get the equivalent resistance referred to HV side. Why equivalent resistance referred to HV side? Because we have shifted the secondary impedance towards the primary. So that is referred to primary, right? So that R naught 1 can be obtained by using this relation, because WSC was nothing but ISC square R naught 1. Correct? This depends on the current. So by this I can calculate R naught 1. Similarly, I can calculate the impedance because I have the voltage and I have the current. Right? And then the leakage reactance. Once I have the impedance and the resistance, I can calculate the reactance also. And of course, power factor. So how do we give the power factor? Because this loss can be represented by WSC is equal to ISC VSC cos. Now I will not write phi naught, because when I write phi naught, naught represents no load, but it is now full load condition or short circuit test. So I will write cos phi SC. Fine. Okay. Yes. So this is all when we calculated all the resistances about primary side. See the subscript. Every parameter has a subscript as 1, 1, 1. Now what happens when we have to calculate these parameters for secondary side? Okay, so I'll just give you an idea, and at the time of numerical solving, of course, we will be looking at that particular aspect also. But here now I'll just tell you how it is done. Okay, so what we are doing is we are shifting the primary to the secondary side. Okay, so refer to secondary. So here this becomes my HV side, which is short circuited. So here V1 becomes 0. Okay, then here I have the ammeter, then I have the wattmeter in order to give me the power. Fine, and then I have the voltmeter, and here I measure the short circuit voltage. Fine, so this is how it looks like. This is I2, this is I2, and this was I1. So this is how it looks like. Okay, fine. So in this case, in the same fashion, I will be writing the parameters. So my WSC would be I2 square into R02. Okay, so I can calculate R02 by WSC upon I2 square. Similarly, I will get Z02, which is VSC upon I2, and then I can calculate X02, which is Z02 square minus R02 square. Fine, okay, but remember here we have shifted the circuit to the secondary side. Okay, so here R01 will be calculated as R02 upon K square. Okay, similarly X01 will be X02 upon K square, both in ohms. Now when to calculate R01, Z01, X01, and when to calculate R02, Z02 and X02, that we will discuss at the time of numerical solving. Okay, I hope you understood short circuit test. So let us summarize today's lecture. So we learned that in short circuit test, LV side is short circuited and small voltage is applied to the primary. Now rated current flows at high voltage side because here no load current was very small. So that doesn't flow. Now here we have short circuited the output. So here instead of no load current, proper rated current flows at high voltage side. Now here the voltage is very small, so core loss will be very small, but since rated current flows, here we will get the copper loss. So current is responsible for copper loss. So whatever reading is given by the wattmeter will correspond to copper loss. Fine. Okay. So since the voltage is small, core loss is negligible. So power measured represents copper loss. And finally, we will say that core loss is negligible. And hence, I naught is negligible. So we will remove it and we will make the equivalent circuit in the simplest form. Fine. So I hope that you have understood this. So today, by this, we will end the lecture, students. We shall meet in the next class.